Question number 5, we have a 6 kilogram block initially at rest, and then it is pulled to the right along a frictionless surface by a constant horizontal force of 12 Newton. So force is given as 12 Newton, mass is 6 kilogram, and then initially at rest, so U equal to 0. Then we have to find V after it has moved for 3 meters. So it has moved 3 meters. So that is S lah. Okay, so we have to find the speed. So this type of questions, when it gives you both the speed and the force, this is actually where you are going to apply work kinetic energy theorem. Okay, so the displacement is to the right here lah. Okay. Okay. So now this is your force, this is the displacement lah. Okay. And then yeah, so we are gonna apply work kinetic energy theorem. That is in your formula sheets as well, which will be given in the exam lah, which is this one here. Okay, so you just have to basically expand dia sendiri lah. Dia just bagi yang macam ni, and then it should be this one here. Okay, where work is this one here. Alright, okay, so now work done is equal to the change in kinetic energy, and we know that work done is equal to F as cos theta equal to half mv square minus u square. Okay, so we know that u should equal to 0, so we can then cancel this, and now we can then just substitute all the values into this formula, because we do have everything now. Oh, but theta is equal to what? It will be equal to 0, because the force and the displacement is parallel to each other. So theta is equal to 0 degree lah. Okay, so V is equal to 2F as cos 0 degree over m and square root there. Okay, so V is equal to, oh, I have to calculate it because I don't remember the answer. So this is 12 times 3 times cos 0 degree over the mass, which is 6 kilogram. So you'll get 3.46 meter per second. Okay, all right, so that is on question number 5. Question number 6, this is on power. Power is, the formula for power is also given. It is number 14 and 15, equation 14 and 15 of your formula sheet. Yeah, okay, so this is basically used when force is constant. This one is when you can use it lah, depends on what information is available. So we have the mass of the box, which is 50 kilogram, lifted through a vertical distance of 20 meter in 3 seconds, sorry. So the distance is 20 meter, time is 3 seconds. Okay, so box lifted vertically, so basically the force is going upwards lah. Okay, so they go upwards, and then we have the displacement going upwards as well, right? Ish. Why isn't it straight? Okay, so this is S. Alright, so sekarang ni power is gonna be equal to delta W over delta T. Okay, so the change delta W is basically just W equal to F S cos theta. Okay, so sekarang ni apa nilai force tu? Force is actually gonna be equal to mg. Mg as cos theta. But how do you know it is equal to mg? If you remember our forces punya force chapter untuk force, which is the diagram, free body diagram, it will be mg. Okay, so it's gonna be mg here and then force here. So if we look at the y component, this will be equal to fmg. Okay, so yeah, so dapatlah f equal to mg, and then we just have to substitute into the formula here. So mg as cos, again 0 degree because they are parallel to each other, and then TE is equal to 3 seconds. Okay, so m is 50 kilograms, so 9.81 times with the displacement, which is 20, cos 0 degree divide by 3. So you will get the power to be equal to 3,270 watt. Alright, so that is for question number 5 and number 6 of chapter 3 and 4.